Hello everyone, welcome and welcome back to my YouTube channel. So let us start the question series with some motivation. So the motivational quote is push yourself because no one else is going to do it for you. So only you which can make your dreams come true. So with this energy, let us solve the questions. So this is the previous year question series, and let us start the first question, which has been asked in the UGC NET Electronics Science previous years. So the first question is the depletion region in a junction diode contains charges that are. So, what kind of charges is it contains? So, the four options are the first one is the mobility donor and the acceptor ion, and then second one is the fixed donor and the acceptor ion, and then the third one is the mostly majority carriers or the mostly minority carriers. So, as we know that if the PN junction is there, so the P and the PNP, right? So if PNP is there, so in the PN junction, there are the immobile ions, right? So it may be the donor or the acceptor. So the answer of this is the immobile, or we can say the fixed, right? So fixed donor and acceptor ion. So the answer is 2. Then the second question, in a full wave rectifier, the current in each of the diode flows for. So in a full wave rectifier, as we know that the waveform at the output we get is like this, right? So what we are getting, we are not getting the quarter cycle of input signal, the 3/4 cycle of the input signal, the full cycle of input signal, no, the half cycle of the input signal we are getting, right? Now the next question is the Boolean SOP expression obtained from the truth table is. So what we can get from this table, as we can see that input are the A, B, C, and the output is X here. So the Boolean SOP, what is the meaning of SOP? SOP is the sum of product forms, right? So how can we write the sum of product forms? We can write like the AB then plus BC like that, right? So if we want to write the sum of product for the given expression, then we have to see the output where the output is 1. So here in this case the output is 1, and then in this case the output is 1. So what we can write the expression for it, that is a bar, because corresponding to 1 the a is 0, b is 0, and c is 1. So we can write the a bar, then b bar, c, plus the next expression corresponding to 1 is that a b c. So I can write as a, because corresponding to a there is a 1, and then corresponding to b there is a 1, so I can write the b, and then the another one is the c bar. So now let us try to find the answer corresponding to that only. So what we are getting, the third option, A bar, B bar, C plus A, B, C. So correct option is C, or third. Now let us solve the second question. That is that is from the network, as we can analyze from here. And the question is, for the circuit shown below, the value of RL and the maximum power R. As we know that in the maximum power transfer theorem, the for the maximum power transfer, the RL should be equals to the RS, right? So the load resistance should be equal to the source resistance, and for that we have to find out the RTH. So to get the RTH, what we can do, we will open circuit this part, and then we will short the all voltage sources. Then what we will get, we will get the 20 ohm, then the 90 ohm, then the 60 ohm, and the 180 ohm, right? So what is the equivalent of all these resistance? So we can find out by using the formula 1 by RTH, that is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, and I can write it as 1 by 20 plus 1 by 90 plus 1 by 60 plus 1 by 180. Then if we will calculate it, then what we will get here, we will get the 12 ohm. So the two options has been eliminated, that this one and this one. Now also we have to calculate the maximum power. So let us solve the maximum power. As we know that the maximum power formula is VTH square divided by 4 RTH. So for that we have to calculate the VTH, right? So let us solve that. So to solve the VTH, what we have to do is we will open circuit this thing, and then we will write the VTH here, and then uh, we will calculate the VTH. So as we know, we can apply the nodal analysis, right? So if we will apply, what we will get, that VTH divided by 180, because VTH and we are taking the reference voltage as 0. So throughout this way the whole voltage will be 0. So VTH by 180 plus VTH by 60 plus VTH by 90, right? Plus VTH minus 10 divided by 20, and that is equals to 0. So now let us calculate that. So what we will get, the LCM will be 180 here, and then VTH, and also we can write it like this, the VTH, then the LCM is 180, and then 1 plus 3 plus 2 plus 9, alright, and then this is equals to the 10 by 20. So VTH, and then the 180 divided by 2, that is equals to the 90, and then VTH, it will be 90 by 15 and 6 volts, right? So if I will calculate the VTH square divided by 4 RTH, then it will be 6 into 6 divided by 4 into RTH. So what was the value of the RTH? That is nothing but the 12. So 6 12 3 by 4, that is equals to the 0.75 watt. So the answer is RTH is 12 ohm, and the power is 0.75 volt. That is the answer number 3. Like, share and subscribe to my channel for more video updates. Please subscribe it and press the bell icon for more video updates.